Hey guys, welcome to another episode. In this episode, we are going to be building a game that's all of you guys are familiar of. This is called Tic Tac Toe. So as you can see, we have the finished game over here. So we have three difficulty levels. One is easy, medium, and hard. And we can also change the grid size according to our wish, so that we can increase the difficulty on another level as well. So in 3x3 mode, if you put easy, you can do like you have a computer player by default for you, and then you can play with the computer. So if you set the difficulty level to medium, then you do reset. Again, it will try to block you from time to time. All right. So let's build this. As always, we will start with an index.html file. I will show you the guys for the index.html and style.css files in the description so that you guys don't have to write all the CSS and HTML by yourself. This will only focuses on the JavaScript side, so that will be much helpful if you really want to focus on the JavaScript scripting side of this particular part. Okay, so I'm gonna copy the styles and HTML from my other screen, and then I will link it to you in the description. And then I'm gonna also create a script.js file, and then I'm gonna check if this is working. Console.log hello. All right, and then we will do go live. So I'm using a live server plugin or extension from VS Code that will make my life easier. As you can see, we have an empty HTML which is working. If you go to console, you can see we have our hello message over here. All right, so now let's get to it. So first things first, we will initialize all the stuff. We will initialize a board array which will have all the, let's say in this case it's 3x3, right? So it will hold a 3 into 3 9, total of 9 values. In case of 4x4, it will be 4 into 4 16 values, so that we can track how many columns the user or AI has been filled. And then we will also set our current player as a starting player, which is X. And then we will also create a variable called letGameActive, which will decide if the game is actually started or it's finished, whatever the status may be. And then we will also create another variable called winner. So if we can track if the game has a winner or if it's going to end in a draw, like that. All right. And then we will also get the difficulty value from the drop down. For now, we will directly set it to easy. Then we can, as goes on, we can change the value dynamically. And then by default, we will also get the grid size value as well. And then by default, it's going to be 3. And then we also need a winning combination to understand. So let's say in this particular scenario, here I have a 3x3 grid, right? So I want to know if the user has made a change. I want to understand like if the next move will make him win or not. So for this, we need a particular combination, right? So this combination will work if the X tries to go in, all this combination will work. If A tries to goes into this combination, that should also work. And this combination should also work, right? This one, this one, this one, this one. So there are like some certain combinations, certain set of combinations we have to calculate mathematically that we can do later on. All right. So let's start the game. So for now, we will just initialize the game using a function as reset game. So this can also be used to reset the game as well. So let's write that function to reset the game, and then function reset game. So inside the reset game, what we will do is we will initially calculate the total board, initialize into the total grid size, into the total grid size again, and then we will fill that array with empty values. So we can use array constructor, and then we will get the grid size followed by multiplied by the same grid size again. And then once you have it, what we have is a full array with the 9 elements. If you check console.log board, and then if you go to the console over here, as you can see, empty values of into 9 basically. So what we can do is we can use fill method. So it's actually an array has a method called fill, And then we will say, okay, initialize all these array values into an empty string. Empty string basically. So if you do that, now you have 9 empty strings. So for now, our grid size is actually 3. If you change it to 4, we will get 16, as you can see. So we can dynamically change this as well by just changing the grid size element. Okay. And then we will again initialize our current player as X. So in this case, we have already initialized it, but let's say you are resetting the game. So maybe the last player was the O1, right? So in order to change it back to X, when you reset the game, we will change it back to X again. And then we will again set the game active to true to make sure that the game is going to be active. And then we will reset the winner element also. Okay. And then we have to show if the game is over, or we have to have, if you look at the index.html file, we have a message element. In here we will show if it's game over, or like if the player X won, or if the player O won, and so on. So we have to clear that element as well. So for now I will get it by document.get element by id message, right? So we can actually initialize it on the top, so we can use it like later on through the code. So I'm going to say document.get element by id message, so which will have, I think the message is called message. Okay, we have it. And then what we'll do is we will reinitialize it to an empty string. So inner text equal to an empty string. Okay, this makes sure that all the elements we have initialized are coming back to the same value again. Okay, and then let's confirm that our board element is also cleared. So we haven't created the board element first. So what we can do is we can create the board element. So we will access the board with the ID of board, right? So we can get it by using const board element equal to document.get element by id board. Okay, now we have access to the board element. Now in the beginning we can make sure that its HTML is completely empty. So for that I'm gonna set it to empty value, and then later on we can call the style on, we can use display grid element to make this look like a grid, right? So if it's 3 by 3, we can use grid repeat and then give the 3 by 3 value, and then it will automatically take it into consideration and then print 3 by 3 value for us. So that's part of the CSS styling, but we are going to use it in dynamically using JavaScript. So board element.style grid template columns, template columns equal to, we're going to make use of template literals, repeat, and then the value inside is going to be the grid size, and then comma 1fr. So if you guys don't know about how grid in CSS works, I suggest you to go through some of the tutorials that's available on internet. And in the future I might do a tutorial on grid CSS itself. Right, so now we can loop through the values of the total board length. So for now I'm going to initialize a loop, and then I will say I less than board dot length, then I plus plus. Okay, so what this does is we have the total board here calculated, right? So we are going to loop through with an I value initialized to 0 until the board length is reached, and then we will create a div element const cell equal to document dot create element, and then inside div. All right, so we have created a div element and then assigned to a cell variable. Now we can also assign a class for it. So class list dot add cell. Okay, and then we need to also, so this cell is particularly this particular single card value, right? So for that to have we have a styling for cell you notice it's here. So cell is here. So for that styling to be applied, we gave it the class of cell, and then this cell needs to be clickable. Then only it will be having a even listener on top of it. Then we can do, if we can check if this has been filled or not, and then based on that we can work on which data it needs to be filled. All right, so for that I will also add an event listener to it. Cell dot add event listener, listen for the click event, and then after the click event we will call a function place symbol with the index. Okay, so we can write that function later on, but for now I will add this cell element into the board element we have already created, right? So we have this board element, and then it has been set to null as of now, basically empty string. We can append that into the board element, and then board element dot append child cell. Okay, so now if you look at our application, as you can see, it's there now, right? So these cells have been created, and the necessary styling has also been applied. If you look at it, our cell board has total of 9 cell with a class, with a 9 div with a class of cell. So that's applied correctly. Okay, so that part of code is working, and then now we have to write this particular function. So when it's clicked, it will throw out an error saying that place symbol is not defined, right? So we have to define that particular function. So we can write function to place a symbol on the board. Function place symbol, which will take an index, right? We are passing the index value over here. So let's check in the beginning itself. Let's check if the game is actually active. Okay, if the game is active, then we can check if the board of index value equal to empty. So necessarily what we're doing is we are checking the board array, and then inside the board array we are checking if this particular index is actually empty or not. If it's not empty, which means that there is already a value over there, so we don't need to do anything on top of it. So if it's empty, then we can put the current player over there. So we will put board of index equal to current player. So as of now, if you notice in the beginning, the current player is actually X. So current player, we have set it to current player as in the particular index, and then we will also need to update it in the HTML. So we are gonna get the current element. So we will do get element by ID board. So which will get the element. I think we can put this board element out on top so we can reuse it. Okay, so now we can just access board element over here, and then here also we can access the board element. Okay, so board element dot children of index. So what we are doing here is we have this board element. So inside the board element, if you notice, there are only children, and the direct children are always a div cell. So it has only that much of children, that's it. Nothing else is like going to be added into this particular div. So we can get the element with the index of 0, 1, 2, 3, 4, and so on. So this is not ideal, but in the future, if you want to include more elements inside this board, then we can give a data attribute over here, and then based on that data attribute we can get, so let's say data index equal to 0, right? And then we can access this data index using here query selector. But for now I'm going to directly use this index value, and then we are good to go with it. Okay, so now we got the current element, and then we will set the current element dot inner text also to the current player value. So if you notice, current player is still X, and then we'll also add a class to it. Okay, so class list dot add current player dot to lowercase. Okay, so what I'm doing here is, if we have a style, so if you notice, cell also has a style of x, and then cell also has a style of o. So if x is the player, then I'm gonna assign x dot lowercase to be assigned as a class over here. So this is kind of a tricky way, I mean easier way to put the class in without actually making any class check on top of it. Okay, so let's check if that's being working. Yeah, so that's working. And then we are getting an error. So place symbol, current place, player, let's add current player dot to lowercase. So let's check. Cannot read properties of undefined. So it's not current player actually, it's current L. Current L dot classes dot add. So if you check now, yeah, so that's working. So the class is being added. Okay. And then we are not changing the value, so it should actually change. So once this is the current player, once the current player has made a move, then we have to toggle that particular player, right? So it is the next player's turn now. So we will call a function called toggle player, and then we have to write out that function. So function to toggle the player. So function toggle player. So we have a variable called current player. So we just need to change that variable into current player is over here. So we just need to change that variable into the other one. So we will use current player equal to current player is equal to x. If it's equal to x, then we will set it to O. If it's not, we will set it to x. So this is inline ternary operator, or inline if condition, if you may, that can be used to finish this toggling in a single line. So let's check if that's working. Yeah, so that's working. So that part is working. So now the next thing would be, like, once the move has been made, we have to make sure that if that that move actually made the game to be won by someone, or like if the game is draw or not, we have to check that particular condition. So we'll write a function for that using check when, and then we will write the function for it. Function to check the game has been won by someone. Okay, function check when, and inside that function we need to get the winning combination first. So we need to make sure that okay, we need to know beforehand what is the winning combination of this particular game itself, right? So that winning combination needs to be calculated beforehand before we check the when condition over here. So for that, I'm gonna declare another variable called let winning combinations, and then I'm gonna create a function for that, get winning combinations, and I'm gonna pass a size on top of size as a variable on it. Okay, so let's create that particular function to calculate the winning combinations. Okay, function get winning combination, the size as a parameter. Now we will create an empty array. Okay, so this empty array will have all the combinations we need to check if that's completed or not. So we will tackle it in this way. So let's calculate all the winning combinations that's going to happen in the rows side. So if you notice, this is like going through 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are the index right now. So 0, 1, 2, this is the one combination that's going to win. And then if it's 3, 4, 5, another combination, and then 6, 7, 8 is another combination. So we're going to get that first. So we're going to say for let I equal to 0, I less than size, I plus plus, and then we are going to initialize the row inside it to get all the row values, and then we are going to do another loop inside calling for let j equal to 0, same thing, j less than size, j plus plus. Okay, so now we have created that. Now we will do a simple math on top of it. Row dot push I into size plus j. So what this does is size is not defined. Oh, it's actually called grid size. Okay, so I'm gonna do this over here and then grid size. All right, so inside the function we have access to the size variable. So if you look at this console.log row, in the beginning we are getting the 0th value. So in the beginning the ith value is 0, and then it coming into the second loop. So ith value is 0, and then the initial jth value is also 0. So inside that loop we'll check 0 into size is actually 3. 0 into 3 is 0. 0 plus 0 equal to 0. So that's the first element, and then jth value increased. Now j equal to 1. So 0 into 3 plus j equal to 1, which happens to be 0 1. And then if jth value equal to 2, and then 0 into 3, which is 0 plus 2. So we have the first row value. We are just pushing it. All right, and then after that we will, after this particular loop is completed, we will push this row into combinations array, combinations dot push row. So if you notice, now our combination should have all these rows values. As you can see, we have an array of array. One is like first combination is 0 1 2, and the second one is 3 4 5, third one is 6 7 8. 0 1 2, 3 4 5, and 6 7 8. So that's the combination part. All right, and then now we will go for the columns one. So columns one, same thing, but the math is a little bit different. So I equal to 0, I less than size, I plus plus, const column equal to empty array, and then we will do for let j equal to 0, j less than size, j plus plus. Okay, and then I'm gonna push the column. So the math here, it's gonna be I plus j into size, just the opposite of this one. So the first one was I into size, here j into size, that's it. And then we will push the same thing into combinations, combinations dot push column. Okay, so for now let's check if this is being added properly. Combinations, as you can see, the first 3 are for the rows, and then the last 3 are for the columns. So 0 3 6 1 4 7 2 5 8. So column has also been added into the combination, winning combinations. Okay, now we have diagonal options. So diagonal, we have only 2 diagonal options. So this one or this one, same thing, right? Only the order is different. And then we have this one, so only the order is different if you go back and forth. So we have basically only 2 diagonal options. So we are going to declare 2 diagonal options, 2 diagonal arrays. Let's say 2 diagonal 1, and then const diagonal 2. Okay, so once we have that, we are going to do the same thing again for let I equal to 0, I less than size, I plus plus, and then here the math is going to be a little bit different. We are going to directly use this one. So diagonal 1 dot push, and then I into size plus 1. Okay, so what this does is, if you do console.log diagonal 1, diagonal 1 is not defined. I messed up the spelling. All right, diagonal 1, and then diagonal 1, diagonal 1. Okay, so if you notice in the beginning, the ith value is 0, and then the size is actually 3. So 0 into 3 plus 1, anyway it's 0, and then the next one is ith value is 1. So 1 plus 1 is 2, 2 into 1, which is actually, wait, size is 1 plus 1, 2, ith value is 1, 1 into 2, it should be 2, right? So I equal to 0, 0 into, no, sorry, my mistake. So 3 plus 1 it should be. So the first loop, it's going to be 0, 0 into 3 plus 1, anyway it's 0. The next value is 1, 1 into 3 plus 1, which is 4. So we got 4 over here. And then here same thing, 3 plus 1. The next loop it's 2, i's value is 2. Here we have 3 plus 1, which is 4. 2 into 4 is actually 8. So we got the 0, 4, 8, right? So that's done. And then the same thing for the diagonal 2, but the math is a little bit different. That's it. So dot push, the reverse of it, I plus 1, and then into size minus 1. Okay, so this should give us the diagonal 2 value correctly as well. Let's check. Okay, so 2, 4, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's also done. We can just now push this into the combinations array. Combinations dot push diagonal 1 and then diagonal 2. So now we have a winning combinations. So now we can make use of this winning combinations, and then we have to return this particular combination to that particular variable. So we will return combinations. Now we have this winning combinations over here. We have got the winning combination. Okay, so now let's just go to a check win condition and then check if that winning combination is already available to us. Winning combination. So if you press on it, yeah, winning combination is available. So we have basically 8 winning combinations, 3 for the rows, 3 for the columns, and then 2 for the diagonal values. So we are going to loop through each of this and then check if any of this particular combination is actually true for any of the player. Okay, so no, not any of the player, the current player. So we will go through for let combination of winning combinations. So this is an for loop, and then we will use is winning condition to initialize to the true value. So we're going to consider all the conditions are true in the beginning. All the like we are considering that okay, this particular game, the winning condition is actually true, and then we will check if let index of combination. So we are looping through the each combination value. Here in this case, the first value will be 0, 1, 2, and so on, right? So we are checking if the board of index, right? If board of index, we have the index value over here, and then we are checking if board of index not equal to current player. Okay, then the winning condition will be false. Is winning condition equal to false. So what necessarily happening over here is that we are going to loop through all the winning conditions, and then inside each combination we are checking if that combination's index value, if any of those index value is actually not equal to the current player value, which means that he has something in between, right? So in case you have this one, this condition, the winning condition is actually 0, 1, 2. So we will go through the first index checking, okay, if the current player is actually O now. So if zeroth condition, zeroth board is actually equal to the O value, it's not. So it will immediately fail, and then we can use break to break out of it. So this loop will break, and then we will repeat the next combination. So if any of one combination is successful, then we can actually say that okay, if that winning condition is true in the end after all this loop has been done, then we can say game active equal to false because someone has already won, and then we will say winner equal to our current player, right? So now we can also display the message saying that message L dot, we have already set up the message L, right? Yeah, message L is here. So we can say message L dot inner text equal to player winner wins, right? So we have an actual working game in our hand. Let's check if that is working. Wait, it should be inside the loop. Okay. And let's see. Here, so player O wins. So winning condition is being satisfied properly, right? And then let's also check for the draw condition. Let's say you check with all the check win condition and none of the condition has actually breaked, and then use the player wins message, right? So if that happens, we will come back to this particular section. So check win happened, nothing is like, the game is not done. But there can be a scenario in which there are no more empty columns to fill. So in this scenario, there are no more empty columns to fill. So in that case, we have to show that, okay, the game is actually a draw. So for that, we have to write another function to check for game draw. Function check draw. So for that, we can do if not board dot contains, not contains, includes empty value. If it doesn't have any empty value, and winner equal to null, and the winner is also equal to null, then we can say game active equal to false, and then message L we can set it to game is draw. So it's a draw. Okay, so that should do it, right? Now what we have pending is, like, if this game can be played with, two players right now. As of now, we can play with 2 players, and then we can calculate if the player O wins or the player X wins. So in the next episode, I'm going to explain to you how we can set up an AI player so that our game movements will be, so we can play as the X1 and then the O will be played by the AI one. And then we can also change the difficulty level of that particular game, and then also the grid size. Based on that, how we can update the winning conditions, and how we can include, like, change the whole layout of the board itself. So try to do it on your own. If you can't, just we will tackle it together in the next one. So until then, keep coding. I will see you guys in the next one.